Okay, in this first video of improper integrals, we're going to look at type 1 improper integrals. Okay, and so they are ones that are of the form a up to infinity, so not a number up there, but infinity, of f of x dx, or we could have negative infinity down here up to some number, or we could have infinity on both bounds. Okay, so all three of those are of the case of type 1 improper integral. Okay, and so this is actually, we're going to treat this as a limit, and we're going to be able to decide if this evaluates to a number if that limit exists. So formally, let's include it here. So if, let's say it this way, if the integral from a to t of f of x dx exists for every t greater than or equal to a, right? So if we're going to go off towards infinity above a, then it has to exist for all values bigger than a. Then we can look at this integral and equate it to this limit, the limit as t goes to infinity of a to t f of x dx, provided, and I'm going to stress this, provided this limit exists. And as we have seen before, not all limits exist, right? So this improper integral is equal to this limit if this limit exists. And if so, we say that this improper integral converges to, let's try that again, converges to that limit. Okay, so we say it is a convergent improper integral and it converges to that limit as long as it exists. Otherwise, that is, if the limit does not exist, we say the improper integral diverges. So there's only two answers. It converges and it converges to that limit, or it diverges. Excuse me. Similarly, we can look at if infinity is on the other end. So we could say if the limit, if the integral from t to a of f of x dx exists this time for all t less than or equal to a, so we're going to go up towards negative infinity, it has to be defined there, then we say this integral f of x dx is equal to the limit as t goes to negative infinity of t up to a f of x dx, and again, provided the limit exists. And we say it converges to that limit, otherwise we say it is divergent. Okay? Now, if this integral and this integral both converge, then we say this integral, negative infinity to infinity of f of x dx, is also convergent. Now we're going to have to look at that case specifically because we do have to look at each one of these separately in order to say something about this. It's tempting to make it all happen at once, take the limit as both of them go to infinity, but that is incorrect. All right. Now, let's look at an example and then we'll come back to this p series here. So we're going to pause on that for a second. So if I have the integral from 1 to infinity of 1 over x dx, that is an improper integral of type 1. Okay? So we are going to consider the limit, and I don't like to equate them because remember the limit, this only equals this limit as long as this limit exists. And I don't yet know if this limit exists. So we are going to go from 1 up to t of 1 over x dx. So now the rules of this is just a definite integral. So everything we've learned about definite integrals applies to this. So we evaluate this integral first, and then we take the limit. Okay, so this is equal to the limit as t goes to infinity. This is the natural log of the absolute value of x, right? And we're going to go from 1 up to t. Or the limit as t goes to infinity, natural log of t. I don't need the absolute value bars anymore. Why not? Minus the natural log of 1. That goes to 0. So really it comes down to this limit right here, which if we remember the graph of the natural log function, as we go off towards infinity, our natural log also goes towards infinity. So this limit over here equals infinity, which means these do not equal, and we say this integral diverges. Okay? Now you might think, well, they should all, if it's a positive value function, perhaps they all diverge. But let's actually consider this one. Sorry. So we're going to look at the integral from 1 to infinity of 1 over x squared dx. Okay, again, we're going to look at the limit. Not going to equate them, strange colors. The limit as t goes to infinity of 1 to t. I'm going to write this as x to the negative 2 dx. We evaluate this integral, which is just a definite integral, applying the power rule. This is equal to the limit as t goes to infinity of x to the negative 1 over negative 1 from 1 to t. Right? So again, we plug in our values, still not ready to take the limit. So this is negative 1 over t minus a minus 1, right? And now as we send t off to infinity, this thing goes to 0, and we are left with a non-infinity, an actual number, 1. So this limit exists, which means this integral equals that limit. And we say this thing converges to 1. So the natural question to ask is, well, could 1 over x converge, 1 over x squared didn't? For which values of p does it converge, and for which values of p does it not converge? And we will handle that in our next video.